Okay, listen dear students. It's very easy. Already first question yesterday we have discussed. Let's see the second question. Now they gave one complex reaction, complex formation they gave. What is that? Let's see. Silver ions, Ag plus ions, reacts with ammonia, forms one complex, then AgNH3 twice plus. See, for this complex we have to find out the ratio the ratio of rate constants for forward reaction by backward reaction we need to find out. See, for this rate of forward reaction, RF rate of forward reaction is equals to Kf, means forward rate constant. Forward rate constant is always is equal to concentration of Ag plus concentration of ammonia whole square. If you are observed this, the rate dx by dt, what they gave? Dx by dt is nothing but the rate is equals to 2 into 10 to the power of 7 into Ag plus into NH3 whole square mole liter square mole square liter square mole square inverse and second inverse, means this is nothing but Kf. What is the difference between both? Is Ag plus concentration of Ag plus ions into ammonia whole square. Then from this Kf is equals to, it is very clear, 2 into 10 to the power of 7 forward rate constant. Kf means forward reaction rate constant. In the same way, backward reaction rate, RB, rate of backward reaction, is equals to Kb into concentration of AgNH3 twice plus. See, if you observe that the dx by dt is equals to what they gave here is equal but not negative, equal to 1 into 10 to the power of minus 2 into concentration of AgNH3 twice plus. If you are compare that both equations, then the Kb is equals to forward backward reaction rate constant. Kb is equal to 1 into 10 to the power of minus 2 will comes. So in the actually what is the question, what they're asking the question, find the ratio of rate constants of forward reaction by backward reaction. Kf by Kb, Kf by Kb is equal to 2 into 10 to the power of 7 by 1 into 10 to the power of minus 2. This 10 to the power of minus 2 is going to upside, then it becomes a 10 to the power of 9. Means 2 into 10 to the power of 9. 2 into 10 to the power of 9. The answer is second option. Okay, 2 into 10 to the power of 9. Okay, students, let's see the third question. Just a minute. In the third question, what they gave? It's very easy, ma. From the pictures only we have to identify the relative rates of these reactions. Okay. See, in this question, third one, the rate expression A plus B is converted into product. For this case, the rate is equals to K into A power 1 and b power 1 means the order with respect to a is equal to 1 and order with respect to b is equal to 1. Okay, now let's see the first vessel means in first vessel how many a atoms are present. This a is equal to they are symbolized these dots red color. Okay, is equal to how many are present? 1 2 3. This is a and this is also a and this is also a means concentration of a is equal to 3a. Okay, next and b is equals to this blue color. How many are present? Equals to 3b means concentration of a and concentration of b both are same. Okay, now concentration of a is equals to concentration of b, okay, is equals to both same in the first vessel. Then the rate expression, the rate r is equals to r1 is equals to k into concentration of 3a into concentration of 3b. Okay, then is equals to 9. Otherwise just you leave it like this r1. Next let's see the second one. The second one red color means a is equals to how many are present? 1 2 3 4 5 6 means a is equal to 6a. Concentration of a is equal to 6a is nothing but 2 times increased, 2 times of 3a means concentration of a is increased by 2 times, but concentration of b this blue color dots are how many are present? 3 only. Concentration of b is equals to 3b only. Okay, now for this case rate is equals to r2 is equals to k into this concentration of b is nothing but 2 into 3a into 3b. Now is equals to 2r1. This r2 is equals to 2r1. Okay, now the relative rate of this reaction in vessel 1 and vessel 2. The relative rates means the ratio r1 by r2 is equals to r1 by 2r1, then is equals to 1 by 2. From this r1 is to r2 is equals to 1 is to 2. The relative rates of the strengths in vessel 1 and vessel 2 is equal to 1 is to 2. For example, this rate in the first vessel rate is equals to 1, then the second vessel rate is equals to 2. If the rate is equals to 2, then this rate is equal to 4. Its rate is equal to 4 means it's 2 times more. The rate of the reaction in second vessel is 2 times more than the rate of the first vessel. See, from this dots means red color dots indicates that concentration of A. Blue color dots indicates that concentration of B. It's very clear. Okay, students. Next, go for next question. Fourth one. It's also very easy. See, A is converted into products, then the rate is equals to K into concentration of A power 0 means the rate is equals to minus dA by dt is equals to K means it is zero order reaction. Zero order reaction. Okay, it's very clear. It is zero order reaction. Now for this zero order reaction at 20 minutes, the rate will be, we have to find out. Okay, zero order reactions, if you are observed that the time intervals 0 to 5, 5 to 10, and 10 to 15. Next, what will comes? 15, 20 minutes will comes. This 15 to 20 minutes, then that moles, number of moles of A, how it is changing. 20 is converted into 18, 18 is converted into 16, and 16 is converted into 14, and 14 is converted into 12. Like that, it will be, it is changing. In that case, the rate is equals to, the rate is equals to change in the concentration, change in concentration of A by time interval, time interval, time interval. So change in the concentration of A for every 5 minutes time interval. How much units are changing? 2 moles are changing. 2 by 5. Then is nothing but 2 by 5 is nothing but how much? 2 by 5 is nothing but 0 0.4. 0.4 mole per minute. Mole per minute. Okay, students, see here the time is changing from 0 to 5, 5 to 10, 10 to 15, 15 to 20, like that. And the concentration of A is gradually decreasing, 20, 18, 16, 14, like. See, in that every 5 minutes, the concentration of A is changed 2 moles. Concentration of A is changed 2 moles. What is the rate? Rate is nothing but change in the concentration of reactants by time interval. See, 2 by 5 is nothing but 0.4 moles per minute. That is the rate of this reaction. Okay, let's see. Next, fifth question. Fifth question, the decomposition of N2O5. N2O5 is converted into N2O4 plus half O2. Means 2 moles of N2O5 is converted into 2 moles of N2O4 and 1 mole of O2. If 1 mole of N2O5 used, it means if produce 1 mole of N2O4 plus half mole of O2 is producing. Now is at 200 degrees centigrade. 200 degrees centigrade temperature is present. The initial pressure is 114 millimeters of Hg. After 25 minutes, the reaction total pressure of the gaseous mixture is 113 minutes. Calculate the average rate of the reaction with respect to atmospheres minute inverse and with respect to mole liter inverse second inverse. In the 2 units we have to calculate its average rate. Now the initial pressure P naught is equal to, only initially N2O5 only present, its pressure is equal to 114 mm. 114 mm. Okay, at if time is equal to t, then the total pressure is equal to, at what happens 114, its some pressure will be decreased. The decreasing pressure is x, and automatically the pressure of N2O5 formed is equal to x, and O2 pressure how much will forms? X by 2 will forms. Then this is equal to, t is equals to 25 minutes time, the total pressure is equal to 114 minus x plus x by 2 is equal to how much? 113 mm. This x and x will cancel, then x by 2 is equals to 113. X by 2 is equals to 133 ma. 100 133. 133. Then x by 2 is equals to 133 minus 114. 114. Then we'll get 19. 19. From this, x is equal to 38. X is equal to 38. Then the final pressure is equals to the final pressure of N2O5 is equal to 114 minus x. 38 is equal to how much? That is 76. 76 mm. Okay, that is initial pressure and final pressure we know. Then it is first order reaction. Decomposition of N2O5 is first order reaction. First order, then n is equal to 1. Now it's average rate. Average rate. Average rate is nothing but what is the formula? Change in the pressure. Change in pressure by time interval. So at time is 25 minutes. Change in pressure, the units is atmospheres, but the change in the pressure we have in mm. So that is change in pressure in atmospheres. The time in minutes. The time is in minutes. The change in pressure is equal to final initial pressure minus final pressure is equal to 114 minus 114 minus 76 by 760 atmospheres. By time is 25 minutes. Time is equal to is on simplification. 114 minus 76 is nothing but 38. 38 by 25 into 760. On simplification, we'll get 0.002 atmospheres minute inverse. Atmospheres minute inverse. Okay, that is the average rate in terms of atmospheric pressure and minute inverse. But in terms of concentration, we need to express. We know that PV is equals to nRT. PV is equals to nRT. From this, N by V is equals to concentration is equals to P by RT. P by RT. Okay. The pressure is atmosphere minute inverse, but here the units are in mole per liter. Concentration is nothing but mole per liter only, and second inverse. Then that minutes we have to convert into second inverse, means divided by 60. Means 1 minute is equal to 60 seconds. 1 minute is equal to 60 seconds. Now, for this case, P value we know that P means the average rate in terms of pressure is equal to P average rate. Rate in terms of pressure is equal to 0.02 atmosphere by minute. Atmosphere by minutes is nothing but 0.02 by 60 atmosphere second inverse, and R value is 0.0821 liter atmosphere second inverse. Liter atmosphere per mole Kelvin inverse. Mole inverse and Kelvin inverse, then temperature is equals to 200 kelvins is equals to 200 plus 273 is equals to 473 kelvins. 473 kelvins. Then the rate is equals to, the rate in terms of concentration is equals to 0.02, sorry, 0.002 by 60 into 1 by R value 0.0821 into the temperature is 473 kelvins. If it is on simplification, we'll get the value is 8.58 into 10 to the power of minus 7. 8.58 into 10 to the power of minus 7. The units are mole per liter second inverse. Mole per liter second inverse. So the answer is 0.002 in atmosphere minute inverse. In terms of pressure, the units of first order reaction average rate is equal to 0.002 atmosphere minute inverse. In the same way, the average rate in terms of mole liter inverse second inverse is equal to 8.58 into 10 to the power of minus 7. How I converted in terms of concentration? We know that PV is equal to nRT, then the concentration is nothing but N by V is nothing but P by RT. So the average rate in terms of pressure, how much we got? 0.002 by 60, that is atmosphere second inverse. So that we are convert into divided by R and T. R value must we have to use liter, atmosphere, mole inverse and Kelvin, that is 0.0821. Temperature is 473 kelvins. So it's just all values if you are substituted P by RT formula, then we'll get the average rate in terms of mole liter inverse second inverse, that is equal to 8.58 into 10 to the power of minus 7. Okay, let's see next sixth question. See, this question is very easy, ma. The initial pressure of N2O5 they gave, the final pressure at 25 minutes N2O5 pressure we need to calculate. The total the total pressure of reaction is 133 they gave. That is equal to 14 minus x plus x by 2. Then x I have find it out. Then x is equal to 38 gave. So 114 minus 38 is equal to 76 mm. That is the final pressure of N2O5 at 25 minutes. So change in the pressure with respect to time is equal to average rate. Okay, the same way the average rate we are calculated in terms of concentration. Concentration is nothing but mole per liter second inverse, that we are calculated. Above that pressure, the average rate in terms of pressure is atmospheric pressure in minute inverse is there. That minutes we are converted into seconds divided by 60. Okay, let's see the next question. Sixth question also very easy. Based on the concepts only. See, A is converted into B and C is converted into D, both reactions. Then here T99, see this first reaction, T99% of the reaction is completed. T99.9% reaction is completed in 4 parts, means it is 4 times more. For this reaction, T99.9% for completion is equal to 1. Both are first order reactions. Both are first order reactions. First order reaction, then the ratio of rate. The ratio of rate constants K1 and K2 they are asked. See, what is the rate constant for first order reaction? K is equals to 2.303 by T into log A by A minus X. This All are constants. This 2.303 and this log a by a minus x are same values. For example, k1 is equals to 2.303 by t99.9 into log a by a minus x. Okay, the same way k2 is equals to 2.303 by t99.9 into log a by a minus x. See, a means 100%, a minus x means 100 minus 99.9 means 0.1. Okay, that is fixed for both case. Now this is T99.9 percentage is nothing but 4, and here this is T99.9 percentage is nothing but 1. Then K1 by K2 is equals to 1 by 4 whole by 1 is nothing but K1 by K2 is equals to 1 by 4. Then K1 is to K2 is equals to 1 is to 4. 1 is to 4 because for first order reactions K is inversely proportional to T. K is inversely proportional to T because 2.303 by T, A by A minus X all are constant same, then the K is inversely proportional to T. Okay, K1 is equals to 1 by, K1 is equals to 4, sorry, in K1 T99.9 is equal to 4, in K2 T99.9 is equals to 1, means K1 by K2 is equals to 1 by T1, T2 minus T1. K1 by K2 is equals to T2 by T1. T1 is equals to 1 and T2 is equals to 1, T1 is equals to 4. Is nothing but 1 is to 4. The answer is fourth option. Okay. See here, so simple logic is A is converted into B and C is converted into D. Both reactions are going in first order reactions and the final concentrations of reactants A and C both are same. The initial concentration of A and D 100%. Now, but we have to find out the rate constant at T 99.9%. For first reaction T 99.9% is equal to 4. The second reaction T 99.9% is equal to 1. Then the shortcut is K is inversely proportional to T. Then K1 by K2 is equals to T2 by T1 is nothing but 1 by 4 is nothing but 1 is to 4. Okay. Okay, let's see next seventh question. A substance A decomposed in a solution follows first order kinetics in a flask A. Means flask 1. This is flask 1 and flask 2. In flask 1 and flask 2, in flask 1 the concentration of A is equal to 1 molar and in flask 2 concentration of A is equal to 0.6 molar. 0.6 molar. Now this concentration is changing. How it is changing from 0.1 molar is converted into 0.5. That 0.5 molar is converted into 0.25. For this conversion, it takes 8 hours. It is 1 t half. It is another t half. Okay, that is first t half is equal to 4 hours. Second t half is equal to 4 hours. In the same way, this concentration of A changes from 0.6 to 0.3 means it is the half. Then T of is equal to 4 hours. So the answer is 4 hours. Let's see 8th question. The energy of activation for the reaction is 50 kilojoules per mole. In the presence of catalyst lowers the energy of the activation energy by 25%. What will be the what will be the effect of rate constant at 30 degrees centigrade? See the first one, initially activation energy EA1 is equal to 50 kilojoules per mole. Okay, it's very clear. Now the activation energy is equal to 100%. Now this 100% of activation energy is 50 kilojoules per mole. Then the 25% activation energy is decreased. Then 25% is decreased means how much? 100 minus 25 is equal to 25 means 75% is present. That 75% activation energy is equal to how much? That is 50 into 75 by 100 is equal to 37.5%, 37.5 kilojoules per mole. 37.5 kilojoules per mole is equal to this 50 is nothing but 50 into 10 to the power of 3. This 37.5 is nothing but 37.5 into 10 to the power of 3 joule per mole. This is the activation energy. We know that K is equals to A e to the power of minus EA by RT. E to the power of minus EA by RT. From this K1 by K2. From this K1 by K2 is equals to e to the power of EA by e to the power of both. What is that? First one is minus 50. Minus 50 plus the second one is plus 37.5 into 10 to the power of 3. 10 to the power of 3 by RT. Okay, that is K1 by K2 value. Okay, see, this is nothing but 50 minus 50 is nothing but K1 by K2 is equals to 12.5 e to the power of minus 12.5 into 10 to the power of 3 by RT. Now you have to apply log ln. This nothing but ln K1 by K2 is equals to minus 12.5 into 10 to the power of 3 by RT. Okay, that ln we have to convert into log means multiplied with 2.303. This negative sign how we remove this ln K1 by K2 is nothing but minus of log K2 by K1 is nothing but 2.303 log K2 by K1 is equals to 12.5 into 10 to the power of 3 by RT. R value is In joules, R value is 8.314. 8.314 and temperature is equal to 300 kelvins. 300 kelvins means 303 Kelvin. Sorry, 300. Sorry, 30 degrees Celsius is nothing but 30 plus 273, 303 kelvins. Now, this is on simplification K2 by K1. This 2.303 is coming right side, it becomes denominator. Is on simplification K2 by K1 is equals to 10 to the power of 2.154 will comes. Then 2.154 value is nothing but anti-logarithm of 2.154 value is 142.75. See, therefore K1 by K2 is equals to 142.75. Then that K2, the rate is equals to K2 is equals to 142.75 into K1. Means due to decreasing the activation energy, how much? 25% of decreasing the activation energy, the rate of reaction or rate constant is increased by 142.75 times. 142.75 times the rate constant value will be increasing. So the answer is first option. See, it's very simple, ma. Initially the activation energy is 50 into 10 to the power of 3 joule per mole. Then activation energy is decreased 25%, means at 75% the activation energy is 37.5 into 10 to the power of 3 joule per mole. Okay, now at that activation energy, what is the rate? The rate. So in that case, rate is directly proportional to rate constant. We know that K is equal to A into e to the power of minus EA by RT. Then K1 is equals to A into e to the power of minus EA plus you write 50 into 10 to the power of 3 by RT. In the same way, K2 is equals to A into e to the power of minus 37.5 into 10 to the power of 3 by RT. Then K1 by K2 is equals to e to the power of minus 12.5 into 10 to the power of 3 by RT came. So you apply that ln E is equal to 1, then ln K1 by K2 is equals to minus 12.5 into 10 to the power of 3 by RT came. That ln we have to convert into LOG. This right side minus symbol is there. For removing that minus symbol, ln K1 by K2 is nothing but minus of ln K2 by K1. Then minus minus will cancel. Then log K2 by K1 is equals to 12.